let's look at another useful protocol, Tftpd. We'll label this section after its expanded name, Trivial File Transfer Protocol Daemon, or Tftpd. This protocol is commonly used to move files to and from systems, such as network configuration files for firewalls and routers and switches. It features fast, connectionless, which means it's UDP-based, file transfers, and is again often used to move files to and fro networked systems. So for example, VoIP phones, Pixie configurations, router, firewall, switch configurations, and so on. Again, it's connectionless, so you won't see any traces when using netstat in the connection table when two parties are connecting or communicating using Tftpd. But nonetheless, it's fast and usually works pretty well in a local area network environment. Try not to use these sorts of protocols across the WAN, again, because if you lose packets, then you'll have broken configurations or broken files, and you'll have to use some other means of confirming the transfer, such as using MD5sum or any other checksum-based utility. So with that said, how do we get it set up on the system? We can use our remote system serve4 as an example, since it's running the later version of the OS, and query to see whether or not it's even installed using rpm query all grep case insensitive for TFTP. And also, Tftp is implemented as two components, a client and a server. Neither are installed on the remote system. Let's just note that it's implemented as two components. Client, which is the Tftp star package, and server, which is Tftp server star package. We can confirm by examining the contents of our repository from the browser, and here's the NTP site from our previous study. So this is the page where we would search for public NTP servers using any of the links that you see here for the various strata level that we're interested in. But while that search is in a separate shell, we'll connect to the location of the RPMs on the Apache web server, Linux CBT Media 1. This will bring down the RPMs, and when complete, we will Control F to search towards the bottom of the page for Tftp. And there we see the client package as well as the server package. So if you need client support allows you to move documents from the local system to a remote Tftp server. It is indeed the TFTP client, analogous to the FTP client in the FTP client server set. So you'd install this program if you need it. And we'll go ahead and install it anyway because it might be necessary or might prove useful. So we'll RPM, in fact we could use yum install, prompting with a yes, Tftp. And this will search the repository for Tftp, and then we see it's installed Tftp. So now when we rerun rpm query all grepping for Tftp, we'll see momentarily that indeed the client package is installed. Let's enumerate the contents of the package. You see that it includes beneath user bin the client and a man page. Man of Tftp returns usage information, which is typically Tftp optional options followed by the target and a command, which in and of itself is optional, that you'd like to have the TFTP run, equivalent to using TFTP in interactive mode. Again, it can be used to transfer files like FTP in either ASCII or binary modes, and you can connect to a host using a given port other than the standard TFTP port, and the commands will include gets and puts. For example, get a given file or get multiple files, put a file or put multiple files. So the usage is really simple, and we have the package installed, but we're more interested right now in the server, which we'll install by using yum and the name of the package, which is tftp-server. Let's go ahead and just one note, before we executed yum install tftp, the reason why the server wasn't installed is because the unique characters in the server include tftp, but also include the dash in server. So we have to indicate the full tftp-server name in order for yum or RPM to recognize and perform the appropriate match. So let's now indicate tftp server. This will install the server package and will enumerate its contents momentarily. Also notice that as a result of installing tftp server, the dependency for ZynetD was met. ZynetD is a super server. Let's just note, so tasks include 1, install TFTP client, which we did using yum-y install TFTP, and install TFTP server, which we did using yum-y install tftp-server. Note, this also installs ZynetD dependency, and that is because TFTP server is controlled by ZynetD, the super server, which means in order to start your TFTP server, you need to enable it via ZynetD. So our next task is to configure and start TFTP via ZynetD, the super server. The configuration files are located beneath etc zynetd.d, and we'll find one for TFTP. So modify this file prior to starting TFTP. Let's return to the shell. Navigate to etc zynetd.d, that is, and you'll see there's an entry for TFTP. If we cap the contents of this entry, you'll see that it includes basic directives, and if we modify it, because we need to change disable from yes to no, let's modify TFTP, and we can change disable from yes to no, or what I like to do is keep 2 lines, disable equals yes, and comment it out, disable equals no, uncommented, and then start the service. So here are some directives that are passed into TFTP server. The socket type ZynetD needs to know. It needs to know how to start the program, and it is a datagram-based service. It's UDP. It has to wait. It cannot spawn multiple instances. It's a sequential connectionless protocol. It will run as root. The binary which will be executed is located beneath user sbin, and it's known as in.tftpd, as are many of the old-fashioned binaries within Linux and Unix are known as, such as telnetd and others. Arguments. By default, TFTPD will expect to serve files from /tftp boot, so ensure that this directory exists. But if you want to serve files from a different directory, then ensure that the other directory exists and indicate it in this configuration file. The protocol will not be disabled, but it is by default. Per source connections, maximum 11, connection per second 102, flags IPv4. Let's save the changes. Now again, ensure that the directory exists at the root of the file system, and it does. You also need to ensure that there's content in the TFTP boot directory for the sake of being able to write a file. So for example, let's say we wanted to save our firewall configuration to the TFTP boot directory. we should go ahead and create that file. Let's navigate to TFTP boot, and we'll touch, this will be for our router, so we'll call it linuxcbt router1.config. So this will be our file, router1.config, that we will attempt to write from the router. Again, the router is going to use the TFTP protocol to save its configuration to this file once we've connected to the router. Then we could also use the TFTP client to download the file, let's say from a different host. Let's find a free window here, and from this window we will log in to the router, the default gateway that is. Now we're on the router, so we want to copy the configuration using copy running configuration to TFTP, and we'll list this as another task. Copy Cisco router configuration to TFTP server. To do so, we'll execute copy TFTP, or copy running that is, config to TFTP, the IP address of the TFTP server, which in our case is 75. We'll confirm the IP address from the command line, 199. So 75.199. But we have to be sure that TFTPD is running. So from the local, or from the remote system that's running the server, we'll execute netstat mul. Here's a usage of netstat to see the UDP listeners. If we turn on P, we'll see what's running. And notice we don't see the TFTPD port. TFTPD runs by default on 69, and we don't see it listening. That tells us that ZynetD is not running. We can do a service ZynetD status to see whether or not it's running, and it isn't. So we need to start ZynetD as part of our configuration and start of TFTPD. So we modify it, and then we execute service ZynetD start to start ZynetD, which will handle all inbound TFTPD services. So now we've started it, and let's go ahead and re-execute netstat mul with the P option to see whether or not TFTPD is running. We'll scroll up. Now notice that we see protocol is bounded with ZynetD to the port 69. This is the default port. We should just note that. Perhaps we'll list it here. Note, TFTPD listens to UDP 69 by default. So when you execute netstat mulp grep 69 to check if ZynetD is listening, this will tell you whether or not TFTPD is up and running and ready for service. Now from the router, we can attempt to copy the running configuration to the server's IP address of 192.168.75.199 as a given file name. That's going to be linuxcbt router1.config. That's the file that it's going to attempt to write. From the full command, the router parses the IP address of the host from this block, and we need to confirm it. It also parses the file name. So we could have simply executed copy running config TFTP and then indicate the IP address and the file name after. Now after pressing enter, you'll see whether or not it's able to write to the remote server. It says the error code 0, received 20581, error opening this particular file, which will lead us to debug, of course. What we'll do is check the varlog messages file on the remote system. That's where ZynetD logs by default. And notice it reads that SE Linux is preventing user sbin.in.tftpd from being able to write to the file linuxcbt router1.config. So the problem here is with SE Linux. So we need to adjust the SE Linux posture to permit writing by TFTPD. And again, this is a requirement for many of the services for certification that you configure the service to work within an SE Linux framework. Now, one other file we may look at to determine whether or not SE Linux is enforcing, although we can tell that it is because it won't allow us to write the file, is etc sysconfig SE Linux. This contains the policy for the system. Currently, it's enforcing, and its type is targeted. So because it's enforcing, the security policy takes effect. However, if we were in dismissive, permissive, or disable mode, that is, we'd be able to write to the file without SE Linux's intervention. And the default Red Hat Enterprise implementation, which carries over from version 4, is the targeted policy, which targets specific network daemons, Tftpd included. So we need to again alter the configuration so that SE Linux is happy with Tftpd or doesn't get in its way. Now, whenever SE Linux denies access, it logs in varlog messages information about that denial, which can help you to overwrite the denial. Let's tail varlog messages to take a look, and you'll see SE Linux is preventing it, and for more information we should execute SE alert followed by this unique code as it pertains to the message that impacts the Tftpd instance. So if we execute it, it provides us with useful information about the error. SE Linux is preventing, this is summary information, a given daemon, write access to the router config file. Here's a description, and here's how you go about allowing access. Now for this particular case, if you execute set SE boolean for Tftpd with the P option Tftpd disable trans equal 1, and then restart the Tftpd server, you'll then be able to write the file. Let's go ahead and give that a try. Once this is completed, we'll restart Tftpd. So execute the following: disables SE Linux for Tftpd. C restart using, of course, service zinetd restart. This will cause Tftpd to be restarted as well. Now let's reconnect to the router. And then we'll execute copy running config to TFTP 75199 as Linux CBT router 1.config. Enter a couple times, and now it's written the file. So, with that said, from the local shell, let's take a look. There we have Linux CBT router 1.config. If we examine the contents of the file, we should be able to see it, and it should be fine. Also ensure that the file is writable by the world. So make sure, we should just note that change mod 666 the file name to permit Tftpd to write, unless you've overridden that feature using the -c option when you start Tftpd. If you man the in.tftpd man page, you'll see how you can override having to flag the file world writable. But you must flag it world writable in order for Tftpd, with the default startup, in order for Tftpd to work. So we've updated the file. It exists. We can examine the contents of it. And there we have it. We can change it from the router at any time. We can rewrite, in other words, and it will update the file. We may also use the TFTP client to pull the file using get. So an RPM query all grep TFTP will reveal whether or not it's installed. and it is. So we could, for example, Tftp and get it from the server. Again, when you execute Tftp, it throws you in the interactive mode, but if you execute Tftp with help, you'll see that you can indicate the command to execute right off the command line. For example, let's just list as our fifth task, instead of the router, use Tftp client to download the router configuration file. To do so, we'll execute Tftp, the host IP address, followed by -c, and get the name of the file. This will download the file to the directory that we're currently in. Let's navigate to our home directory, and then execute by pasting the command. It doesn't look like much has occurred, but the exit status is 0. And now when we LSL Linux CBT router on, we see it. So we've pulled it just like that. And we can pull it from remote systems as well, providing that Tftp is installed. So let's find a window that's free in our local system. We'll log off the router. In RPM query all grep Tftp, which probably is not installed. Or maybe it is, we'll see momentarily. If it isn't, we'll use yum to install it. This will pull it down from the RPM repository, and once installed, we'll navigate to our home directory and execute what we just pasted earlier, which is to connect to the Tftp server and fetch the file. Now we've got the file. Now again, if you don't use Tftp with an option, it puts you into this interactive mode, which prompts you for the various settings. So now we're actually here. ls doesn't work, help does. You can get the file manually, and this will pull it manually in interactive mode. So we should note, well, as an option B, Tftp enters interactive mode. So note, Tftp client operates in both non-interactive and interactive modes, depending on what you've indicated on the command line. So again, we've shown you how to back up your router's configuration, how to adjust the SE Linux policy for Tftpd so that the Tftpd daemon can write to the file, as well as how to pull that file from two distinct hosts. We pulled it from one, the Red Hat Enterprise 5 system, and two, from the VMware instance of that Red Hat Enterprise system, both running 5.x of the operating system. And now Tftpd is up and running. Now to disable TFTP, since we're not using it currently, modify the etc zinetd TFTP file, either manually using nano or using the sed stream editor. And since we've got two lines, we'll just comment disable equals no and uncomment disable equals yes, and execute service zinetd restart, and then of course netstat nulp grep 69 to see whether or not it's listening. And these are sessions that will be killed momentarily. To be absolutely sure that they're dead, this is an opportunity to use the kill command to kill the process IDs that are listed. So for example, 24468 and 432. Now let's re-execute netstat, and those sessions have been killed. psef grep tftp will reveal nothing's running. So this is working as expected. So we've disabled it, and when we need Tftpd in the future, we'll enable it, but we have both client and server installed and ready for usage.